in the 8051 microcontroller. So it has the 5 different interrupt signal that has been the interrupt 0, TF0, INT1, TF1, RI for TI. So these all 5 different types of interrupt signal which is used in the 8051 microcontroller. So the interrupt, first of all, you must aware about the interrupt. What is the interrupt? So while we are executing the program, okay, you need to make any somewhat delay or stop the program by using these interrupts. Okay, the execution time, for example, if you can consider any traffic signal, so particular light, that is the red, yellow or green, whatever it is, so it is based on the time. So the period, a particular period of time, some green will glow and green automatically will getting off, and red will glow and yellow will glow. So that is all sequentially based activities. So during that process, it can able to control the signal flow, or it may start or stop the signal flow. Okay, for that purpose, the interrupter is very essential in the 8051 microcontroller. So it has two different register, that is the interrupt enabled register, that is the IR register. So this IR register plays major role in the microcontroller. It can able to enable or disable the interrupt. Okay, the interrupt in the sense we all know. So the similarly the interrupt, it have two different register: interrupt enabled register and interrupt priority register. Interrupt enabled register, what it will do, it is also the 8-bit. It can able to enable or disable the interrupt. Okay, it is the it is only can enable or disable the interrupt, but the interrupt priority register, it will play the major role, which is the most priority one. Okay, if the simultaneously if you are received the two interrupt, which is the higher priority, so that has been executed, that will decide the IPR. Okay, so it will be decide the which interrupt is most essential, or which is needs to be execute at the time. So based on that, here it will be enable or disable the interrupt. Okay, the IE, that is the interrupt enabled register, can enable or disable the interrupt. But which is the enable, which signal, which interrupt is enable or disable, that has been decided by the IPR. Okay, that is the interrupt priority register. You can compare those two diagram, both are at the 8-bit. Okay, here the interrupt 0, interrupt 1 up to the 7 interrupt, that means up to 0 to 7, the totally 8 interrupt are there. Okay, for the interrupt 0, the enable or disable external interrupt 0. The same thing you can see here, the priority, that is the IP0. So it can defines the external interrupt 0 in the priority level. Okay, so it means that while you are considering the interrupt, while you are, if you want to enable this interrupt, here the IP1, that is the IP, that is the interrupt priority register, here the first bit it should be enabled. Okay, so it can provide the signal to here, so the interrupt 0 it may be enabled. Okay, so similarly the IP1 interrupt priority 1, here the timer is 0, it defines the timers 0, it defines the timer 0 for the priority level. So here also the timer 0, that is the overflow interrupt. So if you want to enable this interrupt, the IP will be give the data, that is the here the timer 1, it should be give the data to the interrupt enabled register 1, that is the 1. If you are passing the signal 1, here it has been executed, or here in this particular interrupt has been enabled. Likewise, all the cases, the interrupt priority 2, that is the external priority interrupt 1 at the priority level, external priority interrupt 1 at the level. So it means the external priority interrupt 1, here also you can see interrupt enable or disable external interrupt 1. This interrupt, if you want to enable, here the IPR will give the signal to the signal 1 or logic state 1 to the IE2. Okay, then only it is getting enabled. Likewise, this also IP3, the same thing, here the timer 1, enable or disable timer 1 overflow interrupt. If you want to enable this interrupt, the IPR, that is the interrupt priority register, the IP3 interrupt, it may be the defines the timer 1. Okay, that is all are assigned for enabling or disabling the interrupt register combinedly, that is the IPR, that is the interrupt priority register. Both are internally connected. for execution of or enabling or disabling of the each and every interrupt. Interrupt 0 to interrupt 7, it can be enable or disable based on the this instruction. It is made for the serial port. There also we are having enable or disable the serial port interrupt, that is the IE port. So it is used for the future use. So the IE7, if you are giving, it can be disable all the interrupt. So if you are giving the EA0, that is the 0 to here, it can be disable all interrupt. Okay, if you want to enable it, so you can give E1 each and every one, that is the individually you can this all interrupts, so you can enable one by one, which is most requirement. Okay, so the IE register and IP register both are internally connected together to perform the task. Okay, if simultaneously if you are received the same interrupt, like both are in the major, both are in the same interrupts in this same level, interrupt level we can define from 1 2 3 4, both are, if it is the both the interrupts are the same level, in the IP register it will be sending into the pulling sequence, internal pulling sequence, then it will may decide to which is the most priority, that it can be sent to the interrupt, then that particular interrupt has been enabled or disabled at that time. Okay, so these are the interrupt we are using in the 8051 microcontroller. The major thing you should remember, the 4 interrupt majorly classified, then IE register and IP register both are you should know. So both are internally connected to execute the particular interrupt during the execution of the program. That's all about the interrupts in the 8051. If you have any doubt, you may ask. Okay, thank you.